Okay, so let's consider this small project that I have here. It's called Calculator, and it consists of an operation class, which is an abstract class, and it describes a general operation between two numbers that are stored as protected members of the class, and these two are doubles. It contains an abstract method called getName, which is supposed to return the name of the operation we're dealing with. Another abstract method which returns the operator, so the symbol that we want to use to trigger the given operation. Then we have another abstract method which performs the actual calculation. And then we have the only known abstract method of this class, which is setNumbers, which takes two numbers as input and stores them in the two class members of the abstract class. I provided two implementations for this operation class. The first is addition, so it basically extends operation, providing proper implementation for getName and getOperation, and the calc method is straightforward, a plus b. Keep in mind that this a and this b, these two members, these two variables, are actually referring to the operation part of the addition class, and that's because in operation a and b are marked as protected, which means that they are not accessible from the outside except for all subclasses that are extending the operation class. The implementation of multiplication is similar, so it sets the name multiplication and it sets the operator and returns the result of the multiplication as calc method. Then we have the main calculator class, which is in charge of with a scanner. It's in charge of collecting the input from the user. So it asks for the first number, and then the second, and then the operator, and then the second number. With this s.nextLine, we're able to retrieve a string representation for the user input. But what we want to do is to convert this operator into a proper instance of the operation class. So here in this line you see that we construct a reference O, and this reference is initialized by this parse operator method, which is a static method of the operation class, which takes a string as input and returns an object with proper with static type operation. So let's see this method, which is down here in the operation class. As said, it's a public static method which takes a string as input, and internally this method has an array containing all the possible operation that we have implemented so far, and it iterates over all of them, and for each of them it checks whether the input from the user, so the string, is equal to the value returned by the getOperator method for each of the operations. If this is the case, then the operation is returned. Otherwise, the next iteration of this for loop is executed, and when there's no more operations left, then null would be returned. So if we go back to our calculator, we need to check first of all if the if our O has been initialized to something valid. Otherwise, we need to print an error. But if something correct was initialized, then we can set the two numbers to the O object, and then we can print the result of the calculation. So if we try to run this code, then you see that it asks for the first number, let's say 5, insert the operator, let's say plus, insert the second number, let's say 2, and then we get the result of addition, which is 7. So please now go back to the video and implement this calculator project. Now that you have your project implemented in Eclipse, let's import this code into GitHub. I have already prepared a repository, so let me copy the URL of my repository, and then when we go back to Eclipse, we open the Git perspective up here, and we can clone a Git repository by clicking the button here, and then we can set the proper URI. Host name should be automatically matched, username and password, and then we can continue. Continue till the end. And once the repository is set up, then we should have it in here. If we go back now to the Java perspective, we should be able to right-click on the calculator project, and by selecting Team Share Project, we have this interface open. So we're going to share this project using Git. Here it asks for the repository that we want to use for sharing this code, and we have this calculator repository already created, so we can now click Finish. Okay, now you see that there are unstaged changes, and those are indicated with this angular bracket here. So if we right-click on the project, we select Team and Commit, we have this window where we see all the unstaged changes that we have to commit. So we can click this plus button, so all of these are then included as staged changes, and we can write a commit message, something like initial commit of the project, and then we select commit and push. Since there's no branch available yet, we this Eclipse plugin asks for the branch that we want to push our changes to, and automatically it provided us with master, which is the branch we want to use for our commit. So we can just click next, and then we have the push confirmation, which indicates that we successfully committed and pushed the changes. So if we finish, then we have this other confirmation again. Now if we go back to our GitHub and we refresh the page, we see that we have one commit which contains exactly the project we were working on and that we just committed. So please try to do it, try to create the repository yourself, and try to commit the code to the repository. Now that you have your code in GitHub, let's go back to our Eclipse project, and let's say that now we want to implement a new feature for our calculator. And for example, let's say that we want to implement the subtraction between two numbers. However, to do that, we don't want to pollute the master branch because we don't want to compromise the stability of the main branch. So we're going to create a new branch to work on the subtraction, and we're going to implement the new functionalities in there. So we can right click on the project, select team, switch to, and we select new branch. We have to give a name to this branch. Let's call it functionality subtraction. Okay, now you see that next to the project name in Eclipse, between angle brackets we have the name of the repository, in this case calculator, and next to it we have the name of the branch we're currently working on. In this case it's funcsub. So now whatever we do in the project is going to affect just this branch and not the master branch. So we can right click on our operation package and we can create a new class. Let's call it subtraction, and it should extend operation. We assign proper name, a proper operator, say minus, and we have to perform the calculation, which is a minus b. We could save that. Now we can commit this code by right clicking on the project. We can select team, commit, and then we can stage this new piece of code and write a commit message. And now you see that the Eclipse plugin asks us whether we confirm that we want to use this new branch in the pushing. And we confirm that, and we confirm that this is what we want to do, and by finishing we're committing this code to GitHub. So now we get the confirmation that this code has been indeed committed. So if we now go back to our GitHub and we return to our main project, then you see that GitHub informs us that we recently pushed a new branch which is called funcsub. So let's now navigate to the calculator and in operations, and you see that here we still see only these three classes, and that's because the branch selected at the moment is the master. However, if we click here, then we see that we have also this funcsub branch, and by clicking here then you see that we have our subtraction class included as well. So if we now go back to our calculator, you see that one commit is reported here, and that's because again the master branch is selected. But if we select funcsub as branch, then you see the two commits that are referring indeed to this other branch. So of course on this branch we can continue our work, and for example we need to modify the operation class, and we need to include in the parse operator method, we need to include the subtraction. So we need to add this new subtraction object to our array. This is needed if we want to use the calculator. So let's try to run this code. Let's say we want to compute 10 minus 3, which returns 7. So this is now good. So now we can commit this second change to the repository, so operation here, and as message we can write operation now available for usage. We can commit and push. Okay, we have the confirmation that the push operation went fine. And if we go back to GitHub, we will see that now this funcsub branch is 3 commits, whereas the master branch is still at 1. What we can do now in our Eclipse project is to still continue working on the master branch just by right-clicking here and selecting team, switch to master. This way you see that the branch name changed to master. We don't have the subtraction anymore, and from operation the subtraction is not available. So please try to create this branch on your repository as well, and implement the subtraction. So now that we have our subtraction implemented in the other branch, we can try to merge this other branch into the master. To do that, we need to select for our project the master branch, and now it is already selected because we have here the repository name space the name of the branch. If this is not the case, we can just right click, select team, switch to, and we can select the master branch. And then to merge, we can right click, select team and merge. Then the system asks for which branch we want to merge into the master, and we select the funcsub branch in the local repository, and then we keep as merge option to have a commit with this fast forward configuration. Then we can click on merge, and then this is what the system prompts us. So these are the two inputs that were ahead. So we can, by clicking OK, now we see that our new our branch master has 2 changes which are to be pushed. So we can right click and select team and push to upstream. This way this dialog confirms that we successfully managed to push our merge back. So if we go now to the online interface of GitHub and we refresh, now you see that in the master branch we have 3 commits, and these commits are basically taking into account the merging that we just performed. So if we now go into calculator and we select and we browse for the sources, you see that the subtraction is in there, and in operation we have the new version of operation which takes into account the subtraction class as well. Of course, the other branch funcsub is still available, and in principle we can continue to work on this other branch in case we want to continue our work, but this is actually not needed. So we can just switch back to master, which is the main branch, and we can continue from here. Of course, the Eclipse package is also aligned in the sense that now the master branch has the subtraction, and in operation we have the subtraction class taken into account as well.